Hello everyone, welcome to this first video on error correcting code, a crucial subject in electronics and communication engineering. My name is Villubhai and today we will explore from its historical roots to its modern application. ECC plays a vital role in maintaining data integrity in today's digital system. This video will help you to understand what is ECC, why it is needed, and the different types of ECC and why it is used in real life. Okay, the advantage, disadvantage, and the all the things. Okay, so this is the history of error correcting code. In 1948, Claude Shannon published a mathematical theory of communication in the Bell System Technical Journal, which laid the foundation for the information theory. Shannon works was also address the problem of how to reliably transmit information over noise channel. He developed the Shannon-Hartley theorem in his 1948 paper, which provided the theoretical basis for developing efficient and reliable error correcting codes. Okay, ECC are essential for ensuring data integrity when data is transmitted over channel prone to noise or interface. This laid the foundation for error correcting code, making it possible to detect and fix errors in digital communication system. Okay, now what is error correcting code? So you can see there are 3 points. These 3 points are very important for you to understand, and it's also you can use for your exam. Okay, for exam perspective you can easily use this point. So that's why I have written in simple words, these are the 3 points. Error correcting codes are mathematical techniques used to detect and correct errors in data during transmission or storage. Okay, they add redundancy to the original data, allowing the receiver to identify and fix errors that may have occurred due to noise interface or other factors. So it ensures the reliability of data, especially in noisy communication environment. So these are the 3 points. But what is actually the error correcting code? Error correcting codes or ECC are very powerful mathematical technique used to detect and correct errors during data transmission or storage. In simple words, they help to protect our data from getting corrupted. It is impossible to avoid the interference or noise, but it is possible to get back the original data. For this purpose, we first need to detect either an error is present or not using error detection code. If the error is present in the code, then we will correct it with the help of the error correction codes. So ECC add redundancy. What is the meaning of redundancy? ECC adds redundancy, extra bits of information to the original message. So these extra bits helps the receiver to detect any errors and even correct them without needing the sender to retransmit the data. Okay, so it's actually used to add a extra bit with the original data to check at the receiving end. Okay, by which we can easily detect the error of the data or the transmitting data. So it's ensure the reliability of data, especially in noise communication environments. Okay, in over the noise environment also you can easily receive the data. That means the original data you can easily receive over the transmission channel. Okay, so now the error correction and error detection plays an important role in transmission of data from one source to another. The noise also gets added into the data when it's transmit from one system to another system. That can be your mobile communication system, or also it can be your the devices which you are using to store the data, which you are using to scan the data, or you are transmitting the data also. Okay, so anything it can be possible, anything you can use, like a walkie talkie also. Like through walkie talkie you are transmitting the data from one channel to another channel, sorry, from one system to another system. So that's why this requires to check the data and transmit the data with the noise after correcting the error or the noise. So the bits of data may change either 0 to 1 or 1 to 0 during transmission. For this purpose we can use the following codes: error detection code and error correction code. So as shown in the diagram, the source sends data to the transmitter, which add redundancy before sending it through a noisy channel. The receiver then uses the ECC logic to identify and fix any error before passing the correct data to the final destination. This entire process ensures reliable communication even in the presence of the noise. Okay, through the camera also whatever you are processing, so that also you can easily detect. That means the original detection you can, okay, original data you can get from. After this error correction or error detection code. Now we will understand where ECC is used, okay, and why it is required. Imagine this: you are sending a message to someone on WhatsApp, but your network signal is barely holding on. Or think bigger: NASA is trying to talk to spacecraft that millions of kilometers away. In both the cases, there's a common enemy is noise. Okay, so no, not the noise you hear. We are talking about the digital noise, the invisible disturbances that sneak into your signal and try to corrupt your data. This can happen over Wi-Fi, through satellite links, or even when you are playing a CD, a little bit of interface, and suddenly the information can be twisted, broken, or lost. But here is the good news: our technology is very smart. It uses something called error detection and corrections. That means if the data gets damaged along the way, your devices can spot the problem and fix it, almost like magic. So whether it's a Mars rover receiving commands, your phone decoding a QR code at the store, or a WhatsApp message in a low signal, error correction is what keeps your digital world running smoothly. So now come back to that real life example. So ECC are used in everywhere, in CDs, QR codes, Wi-Fi routers, 5G, and even deep space communication. So error detection, error corrections techniques are used in real life applications to ensure accurate communications. In satellite communication, data is transmitted from Earth to a satellite through uplink and then back to the another ground station via downlink. During this transmission, noise and interface can alter the data bits. Error correction helps restore the original message. In WhatsApp, end-to-end encryption ensures that even if the data is intercepted, it remains secure and unaltered. This adds a layer of integrity and privacy to digital messages. Do you know how QR code are scanned? So you can see one pictures are over here. So these QR codes have the 4 levels. So level L can recover 7% of data loss. Suppose your QR code is already damaged some of the percentage. So now how it can be recovered? So the level L can easily recover the 7% of data loss. Level M can recover up to 15%. Level Q handles up to 25%. And the level H can recover up to 30%. This is the actually called the error correction. In all these cases, error detection and the correction makes communication systems more robust and reliable. So robust means what? Robust means the strong and able to handle problems or difficult situation without failing. That means in low network also we can able to send the data through WhatsApp, and through Wi-Fi also we can get the data through the uplink and downlink. In communication, it means the system can still work well even if there are noise, interference, or damage. And reliable means that this is actually the reliability. It can give you the more reliable. That means it means the system gives correct results and does not make many mistakes. Okay, so for today's video I will stop here. Next points we will cover into the next video. There we will go little deep into the error correcting code. So don't forget to see the next video. If you like these videos, please like, share, and subscribe my channel to see more interactive videos like this and the subject related videos.